If you made it here, you're going to like this lesson. So here, the only complication we're adding on these substitution integrals is that we now have limits of integration. So upper bound, lower bound, we are evaluating this and getting a constant as our result. Okay, so we're going to learn how to do substitution where we have to plug in these numbers to evaluate. Other than that, it's going to look exactly like the previous lesson. So we're just going to do one example. I think if you made it here past the previous lesson, you're going to have an easy time with this. So notice this expression inside of parentheses has a derivative that is a multiple of 12 of x, right? So the derivative of x squared is x. That's going to be my u. So let u equal 2x squared minus 3. Du is going to be 4x dx. That means 1/4 du equals x dx. Okay, now I'm going to substitute. So u to the 4th on the bottom, and then x dx is 1/4 du. And then I'm still integrating. Now, here's where things get interesting. So this is the integral from 0 to 1, but these are both x's. X equals 0, x equals 1. We need to change them into u's. So that means for x equals 1, I'm going to plug 1 into u. So u equals 2 times 1 squared minus 3, which gives me -1. For x equals 0, u obviously equals -3. Okay, so I'm going to change this integral now from the integral from x equals 0 to x equals -1. The integral from -3 to -1 of u's. And then this looks kind of ugly, obviously. I'm going to simplify it. So 12 times 1/4 is 3 over u to the 4th du. And then that's a power rule integral, right? So it's the integral from -3 to -1, u to the -4 du. And now we're doing a definite integral, right? So we need to evaluate this. And I can actually simplify that a little more, right? And then I'm just making substitutions. So I have -1 to the -3rd minus, careful with your signs here, 3 negatives. So minus, negative, and then -3, also to the -3rd power. Okay. And then this, we could grind this out, or you could type it into your calculator. The result is 26 over 27. So that is the solution to my integral. And that's the solution also to my original integral, right? So by changing these bounds, so when we changed our x equals 0 to u equals -3, and when we changed our x equals 1 to u equals -1, we saved ourselves from having to switch back to x's, right? We could have done that and then plugged in our original x's, but it's a lot more work and we're more likely to make a mistake. So this is something that can save us time doing these u substitutions on definite integrals.